So we will look today in further solving problems with forces. Let's consider next example. We have a body with a mass 5 kilograms. That acted by the force 20 newtons at the angle 30 degrees to horizontal, and there is a frictional force 5 newton in the opposite direction. And let's find the acceleration of the body and normal reaction. We have diagram, so first step done. Let's label all forces. We have, on top of those two forces, we have gravity, 5g, and we have normal reaction. Let's choose axis, x-axis horizontally into the direction of motion and y-axis perpendicular. Let's write second Newton's law in the resolution into the chosen axis. X-axis, we have force 20 Newton. Its resolution to the x-axis will be 20 cos 30 degrees minus 5 newtons minus 5 friction force equal mass 5 times acceleration. From here we can find acceleration that will be equal 1.7 meters per second squared. To find the normal reaction, let's write down second Newton's law in the resolution into the vertical axis. In the y-axis, resolution will be, we have n acting in the positive direction, plus we will have component of this 20 Newton force acting up, so plus 20 sine 30 degrees, and we have 5g down, gravity down, and there is no acceleration in the vertical direction. Body not jumping up, not digging into the surface, so it's equal 0. From here, normal reaction will be equal 5g minus 20 sine 30 degrees, and that will be equal 49 minus 10 will be equal 39 newtons. So again, steps: diagram, label forces, choose axis, write down second Newton's law in the resolution into each axis, and solve for unknown. Next example, we will consider object on the inclined plane. So we have 3 kilogram body is projected up an inclined plane that makes angle 20 degrees with the horizontal with a velocity 10 meters per second. First question is find and there is a friction force of 5 newtons between the body and the inclined plane. First question, find the distance it will go up the inclined plane, and second, what will be velocity with which it returns to starting point. So first step, diagram. Step number 2, label all forces acting. First consider when body moving up. We have gravity, 3G, we have normal reaction, and we have friction force acting down inclined plane. In this case there is no force acting up the plane, body moving up due to inertia, because it was given initial velocity. Third step, let's choose axis. And when we're dealing with inclined plane, the best, except one case that we will be talking later on, we choose one axis along the inclined plane, and because the acceleration will be down inclined plane, so we will choose axis down, and second axis we will choose perpendicular to inclined plane. So let's write down second Newton's law in the resolution into the x-axis. We have resolution of the gravitational force, of the weight force into the inclined plane, equals mg times sine 20 degrees. And also, because it's moving up, so friction force is down, so we have plus friction force, and that's equal mass times acceleration. The only one unknown here is acceleration. Substituting numbers, we can calculate that acceleration will be 5 meters per second squared. To find the distance it will travel up the plane, we need to use kinematics formula. We have initial velocity, we have final velocity. Final velocity will be 0, because at the highest point it momentary stops. And we also have acceleration, initial velocity, final velocity, looking for the distance. So the best formula will be v squared equals u squared plus 2as. Substituting numbers, we get 0 equal 10 squared minus because it's moving up and acceleration is down, minus 2 times 5 times unknown distance. Substituting numbers will give us distance 10 meters. Now, to find its speed with which it will come back to the starting point, we need to make another diagram, because forces will be acting a little bit different. In fact, the friction, instead of acting down the plane, because object will be moving up the plane, the friction will be acting up. So we have inclined plane with the angle 20 degrees. We have it sliding down, so we have now friction force acting up the plane. We have weight force and we have normal reaction. Again, we choose one axis along the inclined plane. In this case we will choose direction, positive direction down, because it will be accelerating down. And we choose y-axis at the right angle. Let's write down second Newton's law in resolution in the x-axis. We will have mg sine 20 degrees minus friction force equals ma. Substituting numbers, we have that mass 3g sine 20 degrees minus 5 newtons equals 3a. From here, acceleration will be equal 1.7 meters per second squared. To find final velocity, we can again use same kinematics formula. V squared equals u squared plus 2as. Distance we have found before, acceleration we just found, initial velocity is 0, you start sliding from the 0 velocity, so substituting numbers we will get that v squared equals 2 times 1.7 times 10, and then we just take square root of this number. Next case that we will consider is connected particles. Typical question when we have two masses on the light inextendable string. That's going over pulley. And let's say we have masses 8 kilograms and we have mass 10 kilograms. Questions are: find the acceleration and tension in the string. Same steps. We have diagram, we label forces, we have 8g and tension up. We have 10g and tension up. What is very important that the tension in the same string, rope or whatever, it's always the same at both ends and it's always directed away from the object. So let's write down second Newton's law for 10 kilogram mass. It's clear that it will be accelerating down, so we'll choose axis down. And we'll have 10g minus tension equals 10a. For 8 kilogram mass, let's choose axis up because it will be accelerating up. So we will get tension minus 8g equals 8a. We have two simultaneous equations. Let's solve them by elimination. Let's add them up. That will eliminate tension. So we'll get 2g equals 18a and acceleration equal g divided by 9. It is equal 1.1 meters per second squared. To find tension, we can substitute acceleration in any of those equations and find that tension will be equal 87.2 newtons. The next example let's consider combination of the connected particles and inclined plane. So we have a plane, a pulley. We have one mass of 6 kilogram hinging vertically, and we have another mass on the inclined plane, mass of 4 kilograms. Same question, what will be the acceleration and what will be the tension in the string. Diagram, label forces. And we also have that there is a friction force acting between the object and inclined plane. The friction force is that friction force we need to find out, because we have acceleration given. Is 1 meter per second squared, but we need to find friction, and angle is 30 degrees. So let's label forces. On 6 kilogram mass we have mg down, gravity down, and we have tension up. On 4 kilogram mass we have tension, we have mg, 4g, and we have friction force, and we have normal reaction. When we're dealing with the connected particles, we are writing down second Newton's law separately for each object. So let's write second Newton's law for 6 kilogram mass. Because it will be clearly accelerating down, let's choose axis down. And equation will be 6g minus tension equals 6a. For 4 kilogram mass, we choose axis along the plane up. And write down second Newton's law in the resolution into this axis. We will have tension minus 4g sine 30 degrees minus F friction equals 4a. Again, we got two simultaneous equations. Let's find friction force by adding them and so eliminating tension. So we'll have 6g minus 4g sine 30 degrees minus friction force equals 10a. Only one unknown here is friction force. Substituting numbers, we can find that the friction force will be equal 29.2 newtons. Then we can substitute it back into this equation, and we get that tension will be equal 52.8 newtons. That's all for today.